On the 9-1A homework, could you please skip the following problems? So if you could skip for me. Sorry, my iPad now. Of course, that's not going to work. Just a minute, people. Okay. So for the 9-1A homework, please skip number 4 at the top. Please skip number 9 and 10 at the bottom. Those use some identities called the co-function identities, which we haven't talked about yet. So please, again, skip number 4, number 9, and number 10. Okay. We're going to do the ones that I have highlighted because they're kind of like a different version of some of these problems. So let's take a look at number 1. It says, find the value of the expression using all of our identities. So if I know that the cotangent is 12/5, what's great about this problem is I know that the tangent is 5/12 very nicely. They're reciprocals. That's why I know that that's a thing. Okay. So any of those that are reciprocals, you can just, flip that fraction over it because it would be 1/12, which is 5/12. But when it comes to number 5, we have a lot more work we have to do. So I would like to now at this time do number 5 with you, okay? Now, they say that the cotangent is negative and that the sine is also negative. And since I know that cotangent is cosine over sine, if this one is negative and this one is negative, that one must be a positive, okay? And then cosecant and sine go together. Sine was negative, so this is negative. So I don't really do any math at first. I will just first kind of look and go, is it positive? Are my things positive? Are my things negative? Okay, so that's all I've done for number 5 is kind of just contemplate what do they tell me about whether things are positive or negative. Okay, so let me show you what I did again. Cotangent is cosine over sine. If this is negative and this is negative, sine's negative and cotangent's negative, cosine better be positive because a positive divided by negative will stay negative. So all I've done is kind of just narrow down what things are, whether they're positive or negative. Okay. So then we got to find some sort of relationship. I don't know anything on, if you look over on the board with the memory quiz stuff, the only one that really is going to get me something is the fact that 1 plus the cotangent squared is equal to the cosecant squared. Now, I know they did ask us for the cosecant, so that's great. Okay. So if we stick in the values, we get 1 plus negative 4/3 squared has to equal the cosecant squared. Now it's just an algebra problem that we have to solve. To square a fraction, square its top and square its bottom. So that would be 16/9. And then just change 1 to match that denominator, so 9/9. And that's what cosecant squared is. So 25/9 is cosecant squared. Now what's going to get rid of a square? Square root. So we just have to use our rules of algebra. So cosecant is going to be plus or minus the square root of that fraction. Now to square root a fraction, just square root the top, square root the bottom, it's going to be 5/3. Now, is it positive or negative? What did we find out about the cosecant earlier? Was the cosecant positive or negative? It had to be negative. So the answer is that the cosecant is negative 5/3. Okay, now let's think about what we found. We found that the cosecant was negative 5/3. We know the cotangent is negative 4/3. The only one left for me to find is the cosine. Okay, now Look what I wrote right here. The cotangent is cosine over sine. Let's write that down over here. The cotangent is cosine over sine. And I'm sorry I used thetas. I'm so used to drawing thetas that I didn't draw a little alpha where they did. If you end up using thetas or x's or whatever, it doesn't really matter. Okay. So they told me that the cotangent was -4/3. Let's put that right there. I'm sorry, I don't have my good stylus, so, okay. The only thing left we have to find, we got to find that cosine, so that's something we don't know. Do we know the sine? If our cosecant was -5/3, what's our sine? -3/5, right? So that's right here. Okay, so our cosecant, remember, was -5/3. We get as a bonus free instantly, oh my gosh, that our sine is -3/5. So sometimes we have to use that. So we could have also done sine squared plus cosine squared equals 1 to find the cosine. So there's more than one way to do these problems. I think I did this problem earlier on first period, and I think I did it differently than what I'm showing you right now. Yeah. Okay, now this can cross multiply. If it's divided on the right side, it can cross multiply, and then it gets -4/3 times -3/5 is the cosine. Now, what can we do mathematically here? Two negatives are going to make a positive. Awesome. The 3's can cancel. Awesome. Our answer is 4/5. Could you have drawn a triangle that fits all this situation? Go for it. Draw your XY axis, draw your triangle. We're trying to get past that. We are trying to use the algebraic equations instead. If you get stuck and you have no other alternative and you can't remember what formula is going to help you, draw a darn triangle. We still know how to do that, okay? So for number 5, you found out that the cosecant was -5/3 and the cosine was +4/5. Okay, so those ones you have, in number 6, kind of set it up similarly to number 5. Now I would like to do 2 of them at the bottom. I would like to do with you number 4 and number 8. Okay, so I would like to do 4 and 8. Remember, at the bottom, skip 9 and 10. We're going to do 4 and 8 together. One of the hints I gave you when it said to simplify the expression was if you have lots of trig functions, change everything to be somehow a relationship between sines and cosines. Okay? Everything is related to a sine and cosine, make them sines and cosines. So secant is 1 over a cosine. Tangent is sine over cosine. Cosecant is 1 over sine. Okay. So that's just my initial, hey, I don't know what the heck they want me to do. I see lots of trig functions there. Let's replace everything how they're related to sines and cosines. So that's just my initial, hey, let's put everything in there. Here's another hint I'm going to give you. So 3 hints for the simplification section. If you see squares in 1, think of how a Pythagorean can substitute in. If you see lots of trig functions, substitute sines and cosines. Another trick is if you see fractions, get a common denominator. Okay. Now, this first parenthesis, they already have common denominators. So we are going to put that first thing as one fraction by writing it as 1 minus sine over the cosine. I just combined those fractions. Now the second one, I can get common denominators as long as I make this piece sine over sine. Just like before, you remember we made it 9 over 9 in that more numerical example. So this second piece is going to become 1 plus sine over sine. Another hint I'm going to give you. These two things right here are called conjugates. Conjugates are going to multiply together nicely, very nicely. Do you remember back in algebra, a plus b times a minus b was the difference of squares? Those are conjugates. They always multiply to give you the a squared minus b squared sort of thing. So the fact that one of these has a 1 minus and the other one has a 1 plus tells me multiply them together. You're going to get something good. When you multiply those together, you get first term squared minus second term squared. When you multiply the bottoms together, you don't get anything good. Just kind of leave the little list of things. Now, okay, let me remind you of the hints I just told you. First hint was if you have lots of trig functions, substitute things in so they're related to sines and cosines. Fractions, add them, get common denominators. If you get squares and ones, think Pythagorean. Well, squares and ones. So let's look on the board for just a minute. If we took our Pythagorean that says sine squared plus cosine squared equals 1, right? One alternative is we could subtract the sine squared to the other side, right? So cosine squared is equivalent to 1 minus sine squared. I can also put the other one on the other side, right? Sine squared is 1 minus cosine squared. If you look up on the board, what is 1 minus sine squared equivalent to? 1 minus sine squared is the same as cosine squared. So let's take that out and replace it with its equivalent. And now what's something that's going to happen is one of these can cancel out with one of those. We get a cosine times a sine. Go back to your board. One of the things we had to memorize was the quotient identity. What is cosine over sine the same as? Cosine over sine is the, what do you think? The cotangent. And now we're done. You're not a problem solver. Or a puzzle solver, that was it. So remember, you guys, it's just kind of like a puzzle. Oh, what is that equal to? I'm going to take that out and put an equivalent puzzle piece in that spot. And then I'm going to try to simplify it. Oh, I got something that has ones and squares. Oh, there's a Pythagorean. What's that equal to? Take it out. Put something that is in there and equal to. So your job is to combine them, see what happens. Substitute in, simplify, combine them, change them, do some algebra to them, and see how it simplifies. You might, I've done identities. I've taught these for like 14 years now. Even I will sometimes look at it and try one thing and think, that didn't work real great, and I'll have to erase it and try again. So know that these are very much a problem-solving sort of activity. They don't always go perfectly the first time you try them. It's just what it is, okay? Let's do number 8. This one will go much quicker. Up on the board, if you look on the Pythagorean identities, I see ones and squares. I think Pythagorean. What is 1 plus tangent squared equivalent to? Secant squared. That's a perfect instantaneous substitution. Now let's go to our reciprocals for a minute. Cosine is 1 over secant. So what's cosine times the secant? It's always 1. So can't we take a cosine times one of those secants? Isn't that equal to 1? Any things that are reciprocals, if you multiply them by each other, they cancel each other out. They give you a 1. So isn't that 1 times secant? The answer goes all the way down to a secant. Now, there are lots of ways to do this problem. You could have distributed. You could have found other ways, and you might still get to the point where it's secant. Or you might get 1 over cosine, which becomes a secant. However you slice it, that should get all the way down to a secant. So tomorrow in class, we're just going to keep working on these. So please, 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 we're going to do probably maybe 10, 15 minutes of notes tomorrow, 10, 15 minutes of notes the next day. We're just going to keep working on these and working on these. We're going to practice them next week. Memory quiz is Monday. Memory quiz is Monday.